So the title of this presentation is Using SaltStack for Event-Driven Continuous Integration, which is an awesome grab bag of buzzwords that everyone is using in every title of every talk ever at SaltConf. So what I really mean by that is I'm about to spend the next 35 minutes, give or take, depending on how charitable I'm feeling about questions, talking about me and my team and the stuff that we've done with Salt and a bunch of things we screwed up and some stuff that we think we got right that seems to be working for us for now. Now my team is very small. I come from this company, Authentise. I'll talk about them in a minute. If you come from an organization that is very large, my expectation is my talk won't help you very much. If you decide to get up and leave right now, I won't feel bad. There's way more big organizations here than I actually anticipated. I really like Salt for small teams, small businesses, and I think it's a really good fit there, surprisingly. Turns out a lot of big businesses feel like it works for them too, which is cool, but this is really not going to be pertinent to you guys. Okay, mad dash for the door. All right, great, thanks. So I'm Eli Ribble. A little bit more about me. I got a bachelor's and a master's degree from the University of Utah. Yay. We're just up the hill. I appreciate that. That was about the response I was expecting. After the university, I spent a little bit of time as a researcher and made my way eventually to a little company called Wavelink. And we did mobile device management. This was back before Android was really a thing. So this was actually a lot of Windows CE and Windows Mobile. Embedded scanners. Maybe if you've seen those cool things that your UPS delivery truck driver carries and scans stuff. Yeah, we managed those. It was exciting. I went from there to a company called HireVue, another great local company, also pretty small, though they're getting bigger. Yay for them. Where I was one of the initial engineering hires, and I led the platform team for a while. We started off with Chef. Boo, Chef. We started off with Chef. In those days, Salt was actually very, very new. In fact, Tom came and visited our office at one point to make a pitch for, you guys should use Salt. And we said, that looks really neat. And he said, yeah, we can do all this remote code execution. We were like, that's cool. So what happens if a response doesn't come back? And he said, well, then you don't get a response. And we said, well, do you at least tell us who didn't respond? And he went, we're working on that. We said, that'll be really cool in a couple of years. And he was right. It was really cool in a couple of years. So we ended up doing a migration from Chef to Salt at HireVue, and that was a neat experience. And now I'm, of course, CTO at Authentise, which is a neat sounding title for a very, very small thing. I have a team of 6. I'm big news. But the cool thing was, coming to Authentise, we were able to do Salt from day 0, at least my day 0, not Authentise day 0. I'll get to that in just a second, which makes for kind of an interesting perspective in a small group, getting started with Salt, doing their infrastructure stuff from the beginning with that approach. A little bit about what Authentise is. 3D printing is cool and exciting. It's kind of a hot area to do a lot of businesses, including us. A lot of people are doing 3D printing in sort of a lab setting where researchers kind of work on different approaches. They hack out some CAD modeling data. They walk some data across on a USB stick, plug it into a device that manufactures parts. It manufactures a part several hours later, and that's really neat. The problem is you can't scale a business off of walking USB drives back and forth or onesie, twosie building stuff. So our business is all about automating this. So we ingest CAD data, keep track of it in a cloud platform. You say, I have the intent to produce a part with this CAD data. We go, great. We will create instructions for your printer. And so we create G-code or some sort of toolpath instructions. We send it to the printer. We get telemetry data off the printer. And then we secure all of this with cryptography and provenance and all that stuff. We use role-based permissions. Neat things, but essentially it's enabling people who want to go from I do 1 to 2 prints a day to I do hundreds of prints a day with various types of digital manufacturing devices. So that's kind of where we're at, and that's going to color a lot of our experiences with Salt because that's a long-lived process. We do have a web platform, but it's not like we're doing thousands of requests per minute or anything. There's not a reason for you to be wailing on my web service to find out if your 12-hour-long print has proceeded another 0.1%. Okay, so a little bit of history on Authentise. I joined in 2014. At the time, we had no source code management at all. I say none. I'm lying a little bit. There was a couple of projects that had a little bit of Git, but there was also some projects that were emailing source code about, so we'll meet in the middle and say none. There was no unit testing. Again, I'm lying. There was a little tiny bit, but really no continuous integration to speak of. And there was no server management. I'm not lying at all there. That was like, we're going to spin up an EC2 instance, we're going to SSH into that thing, and we're just going to bang on it until it can handle web requests, and then we're going to leave it alone. And that's how we rode. At the time, the team was one senior developer who was overseas. So the headquarters for the company is actually over in Mountain View, California. Senior developer is in Thailand. A junior developer who had just barely gotten his first degree, which was very exciting, and an intern who didn't have anything remotely like a degree. So we started out with not a whole lot. And this is, of course, not to dog on Authentise when I started or anything. But what I want to demonstrate here is how with a relatively small team and humble beginnings, and not very long and not a huge investment, you can use Salt and do some really amazing things. And kind of my point here is to say, okay, big organizations use Salt, that's cool. Little organizations can use it too, and they can get a lot of mileage out of it with not a lot of investment. Oh yeah, and if I'd gotten all the employees in a room together, I could not have gotten enough information out of them to deploy all of our software. It was kind of awesome. It's like, how do we even build this? We don't know. So-and-so did it 6 months ago, and he left, and it's on S3. It's released. Hopefully, we'll figure it out. And we did. OK, so what do we have now? We've got about 1,000 unit tests across 27 repositories. We do a microservices architecture, which works well for us. Not everybody should do it. But it works well for us. So lots of tests across different repositories. We have automatic code deployment. So you commit, you push, stuff happens, and then your code is deployed automatically. Yay. We do active as well as passive server monitoring. So for those of you who want me to be particular about my nomenclature here, active in the sense that there's a process that is hitting the service going, are you alive, are you alive, are you alive? And passive in the sense that it's gone quiet, something's wrong, or we've captured an exception, let's do something about it. We have both of those. We run about 40 servers, give or take, any given time. I know it's not huge, but it's pretty big for us because my team is just 4 senior engineers. I'm one of them, even though some of the time I wear a management hat, and 2 junior developers. So not a very big team, and we haven't invested like tens of thousands of hours into this. I mean, it's been 2 years, and maybe tops 1,000 hours total we've put into it over the course of those 2 years, kind of onesie-twosie as we build stuff. So we're pretty excited about it. All right, so how did we do it? Well, discipline's important from day one. There's a few things that we did. One is we committed to tools. That's really important to us because it's very easy to get kind of like shiny object syndrome where it's like, well, I could make this a little bit better, or we could pull the latency down a little bit more. Our business is not in building continuous integration tool chains. It's fun, we like it, it's cool, but that's not our business, unfortunately. So it's really just continuous integration serves a business function. We do code reviews. Every piece of code gets reviewed by at least one set of eyes before it continues on. Very important to us. Also, part of your code review had better be tests. If there's no tests, it doesn't go. This, of course, leads into automated deploys. Pretty much everyone here kind of gets the whole mantra of infrastructure is code, right? So since we code review everything, and since we don't manually deploy anything, that implies that we're code reviewing all of this automated stuff that's going to deploy to our servers. We didn't start with automated scaling, of course. That's kind of a big jump from I don't manage my servers outside of SSH to automated scaling, but eventually we got there. Once you start building up the different pieces, assembling them in an automated way is surprisingly easy. And one of the biggest, most important things to me is being on call, which is not optional. If you have a subset of engineers that are on call, then you have a subset of engineers that actually care about how deployment works. And that's just like the long and short of it right there. So everyone's on call, even the junior people, which sucks for them, and it kind of sucks for all the senior people during the time they're on call because they can't do a whole heck of a lot without seniors, but it gives them the exposure to, I care about how my code gets deployed, I care about uptime because I don't like getting phone calls at 2 a.m. I said we committed to our tools. What did that look like? This is what it looked like. And I'll apologize to my developers, they are not tools, but they are the prime motivator behind tools moving, so they get to be on the tools chart. So our developers do something, generally of the form git commit, git push. It goes to Bitbucket. Bitbucket goes, yay, thanks, chief, and then tells Jenkins, hey, I got new code. Jenkins pulls the code down, runs the unit tests, provided they all pass. It tells Salt, hey, Salt, deploy this baby. And Salt does, it high states, and all the servers get the new code. Yippee skippy. So this is basically what we set out in the first couple of weeks after I got there. And it wasn't that big of a deal. We'd run Jenkins before. We had some people that had some experience with Jenkins. Bitbucket's kind of a known quantity. Git's been around for a while. You know, Bitbucket, GitHub. Ask me sometime why we picked Bitbucket over GitHub. Maybe it's interesting, maybe it's not. But, you know, Git, Jenkins, very standard. Salt at the time was not terribly new. I mean, it was only 2 years ago. It was fairly proven. So we picked stuff that was kind of easy. This is how it worked. For those of you who don't speak Jenkins, this is, of course, the icons from Jenkins. It has a bunch of jobs. Let's take a given job, something like Blue Whale, which is our log streaming aggregation kind of service. Our customers, we're pulling logs in basically from their systems and then doing stuff with them. Blue Whale is going to have a downstream project called deploy dev backend. And when Blue Whale finishes and the build is green and everything's okay, it runs that downstream project. And that project is actually going to talk via Salt API to Salt and say, I would like you to high state the following servers. And of course, because it's called backend, it's going to high state all the servers whose names are backend. It was really that simple. And different services would high state different servers in different ways. But essentially, Jenkins knew about our server naming pattern, and it would use the Salt API and go, I'm twiddling you, high state. And this had some really great pros, honestly. First off, it's Jenkins, which is a tool that's been around, again, since the dawn of time. And everybody knows. And so it was really easy. We knew how to make Jenkins do this. There was a little plugin for the Salt API. We installed it. We wired the thing up, did a little bit of opening some ports and setting up some authentication, and Bob's your uncle, we can make the two of them talk to each other. And it felt like a tight integration because the job either passed or failed, and if it failed, it didn't do the downstream job, and we had these nifty little green lights, and it made us feel really good, and we liked it. Plus, it made us feel kind of cool, the fact that we were using the Salt API, because none of us had ever done it before, and it was like, look at us, we're developers. We used an API. And I don't want to make fun of the Salt API, because it is really cool, and I encourage people to use it. Just don't use it this way. It's a bad idea. Oh yeah, and so Jenkins, of course, we had that tied into Slack, just like everybody and their dog. And so it was, once we had these two wired together, it was like, oh neat, now we know that Salt is deploying stuff because we've got this channel for Jenkins and we get the little green dots in Slack going, hey, stuff was deployed. And life seemed really good. Jenkins was at the middle. It was our continuous integration server, so it was a continuous integration solution to a continuous deployment problem. But honestly, there's a bunch of things that are kind of bad about this, and you could probably tell since I was saying don't do this. One of the biggest is that Jenkins had no way of knowing if Salt actually succeeded. See, the problem is the Salt API plugin, it's checking the HTTP layer status code saying, did the HTTP request succeed or fail? It doesn't have the smarts to go, oh, you're high stating. Yeah, I'll read through all these states. Yeah, one of them failed. Yeah, this didn't work. No way. So it was really just going, yeah, pretty much everything works. If your network works and Salt's up, yep, we're good, green, everything went. And it could be completely like flailing about on these servers. And we had no idea unless we dug into it, which was another problem because the way that the Salt API works is you tie up a Jenkins worker process, it makes the request, and then it sits there doing nothing, waiting for the response to come back. It doesn't give you output. It doesn't give you progress. Eventually, Jenkins uses a heuristic to say, I think this will take about 5 minutes because I've done it like 100 times. But you have no idea what comes out. And when it comes out, it's just this giant JSON blob of text. And I don't know about you guys, but after doing Salt for a while, I get really, really accustomed to my high states being in colors of greens, blues, and reds. It talks to my lizard brain. And I scroll through and I go, green. Green's good. Oh, wait, there's red. No, red's bad. Red's like blood. And Jenkins gave me none of that, and so my lizard brain didn't kick in, and none of it really worked. So it didn't work. Yeah, and coupling your Jenkins deploy to Salt's kind of a bad idea. If for any reason I need to shift around responsibilities, like say make a backend server now in charge of some new service, it means I have to dig through Jenkins and figure out, okay, which services are bound to which servers and how are they high stating them and pick it all apart and fix it all, which is just dumb because that shouldn't be Jenkins' job. It's not good at it, as is evidenced by the fact that it needed a plugin and me enabling this API and making them talk together and that they don't speak together very nicely. And really the final problem is that we didn't have a scalability story. And that may not be fair in the sense that one could probably use Jenkins and code out a bunch of different Salt API calls and make your scalability work, or maybe have it trigger some sort of, I don't know, runner or something that would end up doing everything you needed to. But that feels really kludgy to me. It's like Jenkins' job is to run tests and to greenlight code. Its job is not to figure out how you're, how to do the marionette strings on all of your little minions to get the code out there. At least that's our opinion. I feel a little bit bad saying that because I'm well aware there's like 3 other talks on the agenda that are like, use Salt with Jenkins, make Jenkins the center of everything. I don't know. This is what worked for us, and this is what happened to us. And that's the whole point of the talk. So here's the new way that we did everything. We have developers, they push code. Bitbucket then tells Jenkins that it needs to build the code, which it does, which then tells Salt to high state that, okay, yes, this is exactly the same graphic, and very little actually changed. Except we started to feel like it was more like this, which is really kind of cool. So instead of Jenkins reaching into Salt and being like, I will now make you high state your minions, instead, Jenkins starts emitting events. And the only thing Jenkins does is it says, I have just finished building Blue Whale, and all the tests pass. The end. And now like SaltStack, the Burninator, comes in here and goes, I will now devour your village and destroy servers and build new servers. And it becomes like this amazing thing. And all that happened was we just changed who was responsible here. Jenkins used to be the one reaching in and managing everything. Now instead, Jenkins just goes, okay, I'm done. This project's good. I don't know what you're going to do with it, dude, but I'm sure it's going to be epic. And this is what that looked like from Jenkins' perspective anyways. Instead of having a whole bunch of deploy dev backend, deploy dev web, deploy dev foobar, whatever, we had one job called salt event. And that took in one parameter, which was the name of the project that just successfully built. And this became the downstream project to everything. So you get green lighted on Blue Whale, for instance. It goes salt event, Blue Whale, boop. And Jenkins goes, okay, 1.5 seconds, I have emitted that event, which is kind of sad because you should be able to emit events a lot faster than that, but I think there's some artifacts of our setup pushing things around between builders and stuff like that. But anyways, it was much, much faster. It used to be like between 5 and 10 minutes, now 1.5 seconds. I was happy, and all the logic could go into Salt, and it could become this epic thing. So what did it actually look like in code? When I moved all the stuff out of Jenkins into now we're going to do deployments via Salt, this is literally all of the code that I wrote that first go. 22 lines, and most of them are just mappings between service names and server names. So for this particular project, Salt says, I need to high state these particular servers. And yes, we use a bunch of really weird, funny names for our projects. We think it's fun. You guys don't have to work with us, so you can live with it for now. But really, like the crux is lines 19, 20, and 21. Hopefully you guys can read that. If not, well, imagine real hard. But essentially all you're saying is, here's a pattern, high state those. And this is just a reactor. No big deal. Really easy when we switched over. And it was really great, except then we didn't really have a way of knowing what was going on. So we decided, let's see if we can figure out how to integrate with Slack again so we can get back to where we were, where we get these nice little green Slack messages. And this is all of the code that it took. And actually, the first go was at the lines 3, 4, and 5, but then we decided we really liked the colored dots. So we took the time to break them apart and go, well, if it worked correctly, then we'll show a green dot versus a blue dot or a red dot. And that kind of mucked it up with all this ginger crap. But the basic essence is really short. We made a runner that all it does is send a Slack message. It's like 4 or 5 lines. If you email me, I could email it to you after I take out our API keys. And so we're formatting messages. We're pulling out the job ID. We're pulling out what function was run and things like that. And hopefully at the bottom you can see this is a little screenshot from what our Slack messages end up looking like. I started a new job. There's the job ID. It's going to run on the following minions. Boom. Yay. It tickles all the fuzzy things in my hindbrain that says I get alerts. Wasn't even a big deal. So now we've got this sort of layout with our continuous integration tools. We're still pushing through Jenkins. It goes to Salt the Burninator, which is becoming this big, beefy Goliath. But now we have a way of feeding back information to developers from Salt directly. And we get push notifications on our phone and stuff like that. Pretty great. It also ties into I can get feedback immediately. And because we're posting the job IDs, Whereas previously, Jenkins was running, and we'd get nothing and nothing and nothing, and then all of a sudden, boom, like 20K worth of JSON. Now it's, here's a job ID. If you care, you can go log in, and you can stare at the output as it comes across, or you can look it up, or whatever, which was great when we needed to actually figure out what was going on, which happens, surprisingly enough. The big problem there is Slack is cool, and it makes me feel good, especially when I have my manager hat on. I go, I feel like I'm in control. I know what's going on. All right, things are good. But the problem is humans suck. They're really slow. They're ugly bags of mostly water, and we really want to take them out of the loop. That's the whole point of this conference almost, is it's all about automation. So how do we get rid of the people? Well, our first thing is to bring in Monet. I may be pronouncing that wrong. I've only read it online. You'll forgive me, I'm sure. This is an active monitoring system. It's pretty cool. I didn't set it up. Don't ask me tons of questions about it, but it essentially uses a simple domain-specific language to identify, okay, every 5 minutes, I want to pull the following files to get PIDs out and see if those processes are still running. Or I want to make an HTTP request and see if I get a response that looks like this. And if I don't get a response back within 3 time periods, I'm going to panic or do something or restart a process or wave a flag or whatever. So this is how we do some of our active monitoring stuff. The other thing we added was Sentry, which I think almost everybody in the world knows about now. It's written in Python, which makes it inherently better than everything else, particularly Monet, which is not. And this basically sits between the kind of the Nginx layer. Nginx is our web servicing process, and the Python VM layer. So it sits there, and our applications, which are written in Python, kind of get boxed by this general exception handler. And if they don't handle their own exceptions, Sentry will catch it and then push it off to a server and go, this process had this exception. Here's the stack frames. Here's all of the local variables. Here's all of the information about the request that caused that problem that came from Bangladesh. It was somebody using IE7. Here's their IP address, blah-de-blah-de-blah. And it captures all that information and aggregates it for us. So these two end up being two very important halves of our automation system. On the one side, we're down at kind of the system layer, and we're actively like poking things. On the other side, we're reacting to problems at our application layer so that we can check kind of the logic up and down the stack in various ways. So we added these to the system. This is what Monet looks like. I probably should have been showing this when I was talking about Monet. Oops. But basically, we've got a bunch of database checks. So different databases, we check them periodically. Monet keeps track of how frequently they look like they're okay, what their exit value is, things like that. It also is looking at CPU load, memory utilization, all that stuff. And it is sending this out to Salt, bloop, every time it runs. And we tweak these based off of the service. Some of our services are a lot slower running, so we don't need the periods to be quite as quick. Others, less so. And one of the interesting things about Monet is that it can attempt this rescue versus escalate. So if a process is down the first time, it can try to bring it back up. If that succeeds, it just kind of figures it was a non-event. If it fails, then it can escalate and say, something might be wrong. I don't know, maybe my hard drive blew up. Help, help. This is what Sentry's dashboard looks like. For those of you who are Pythonistas, 1, good job. 2, you'll notice attribute errors and runtime errors and stuff, very Python. So this is actually capturing Python level exceptions, grabbing them, aggregating them. The spikes on the left-hand side means somebody did something really bad and a bunch of our processes all started dying at the same time. That was when I took the database offline. You can see, I think I admitted to that. And it keeps track of who's doing what and things like that, and gives us a really nice sort of application level overview of things that are going on. The other cool thing that Sentry does is we can tell Sentry, hey, the application that is working with you right now is version X. It's tied to get SHA Y, so that we can partition off our errors based off of what the get SHA deployment is or what the version is right now. That becomes really important when we talk about rolling deploys in a little bit. Okay, so now we've got this closed loop. So this is my infrastructure. Again, developers Bitbucket Jenkins, that's not going to change. That should become really obvious. And Salt the Burninator is just getting bigger and beefier. It's got one of those cool arms growing off the side, and it's ready to burninate peasants and stuff like that. But now we've got Salt telling Monet and Sentry, hey, I've just done a new deployment. Let me know how it goes. And Monet coming back and Sentry coming back going, yeah, things are looking pretty good, or things are not looking pretty good. Maybe we should not do that deployment anymore. And the whole time, Salt can be providing information to developers going, ooh, Monit's saying things aren't looking so good. Did you do something bad? And then I can go and guilt them into staying late and fixing things. Closed loop's really important to us in 3D printing, and it's important to anybody who's into automation. That's the only way that you can start to build a system that mimics intelligence and a system that lets you sleep at night. So how did we make scalability happen? Our system is honestly not super interesting from a scalability standpoint. 3D prints take a really long time, not a lot of HTTP requests. So we don't really scale a whole lot at like the web worker level. We've got Nginx, and it can essentially like round robin load balance between web workers. Request comes in, it dispatches them out. We don't scale a lot at that level. Most web workers are going to end up throwing a job on a queue. In this case, we use Celery. It's Python because Python's the best. It could be any other queue. We've used SQS. It was expensive. I regret it. But we have this stuff going to the Celery queue. And then we've got a bunch of back-end workers. And that's really our bread and butter as far as scalability goes, is these back-end workers and these long jobs. When you're doing 3D operations on CAD files, or you're doing slicing or healing or packing or all of these different back-end things, the back-end's really where it's at. So what we did is in the queue, we have a TTL, time to live, of course, where a message enters the queue and we can say, you need to be serviced within 60 seconds. If you are not, you are dead. And because Celery uses Rabbit, what that means is it goes into another queue. And that queue's entire purpose is to capture these dead letters. We have a little worker that sits there. That worker does two things. One, it detects that there are dead letters, and then it tells Salt, like your kid running to tell your wife when you're playing video games or something. And the other is that it puts the message back on the queue so it can get resurfaced. And that way, Salt can be sitting there, minding its own business. Suddenly, a little kid runs up going, we've got messages that are timing out. Obviously, we have too much load in the system. What are you going to do about it? And Salt usually goes, chill for a second. Another kid shows up. He goes, all right, now we can panic. And then it starts spinning up new resources. And those resources will then just naturally start handling the additional load in the queue because the message goes back into the queue. And all of the workers are pulling from this queue to get jobs. So new workers, more workers, queue drains faster. Life is good. So how do we downscale? Once we've upscaled, because, I don't know, the entire world is 3D printing Yoda statues, how do we downscale again? We use a tiered approach, and this works pretty well for us. And I'm not really an expert in this area, so your use case may vary, but this is ours. Essentially, Monit is sitting there saying every 15 minutes, I've processed 2 jobs in the last 15 minutes. Salt is going to have some sort of notion of what each service should be doing, what its general throughput should be, and after it falls below a certain threshold for a while, it's going to pick usually the oldest server, but there are heuristics we use, and say, all right, I would like you to temporarily shut down your ability to service jobs. It's not going to shut down the server, and that's really important, because it tells it to temporarily do it, because that's an operation that costs less than a second, and then it can sit and monitor and go, okay, what's the throughput on the rest of my services? Still looking okay? All right, we're good to shut the server down. So after it's had enough time, let's say it was a spike, but in the opposite direction, like a sudden drop in load, but it was going to be very temporary. What we want is to shut down the capacity, discover that the spike is gone, and then we want to turn it back on and respond within sub-second. So that's why we do it that way. Part of that also comes from cost optimization. We get billed, if we use an hour, regardless of if that hour is 1 minute or 59 minutes. So we don't want to be up and down servers all the time. We want to kind of balance that out. So we do that by this sort of backoff strategy. So eventually, Salt's then going to say via Salt Cloud to our hosting provider, in this case Amazon, but in other cases it might be somebody else. All right, this server needs to be offline, shut her down, and when it gets shut down, we actually get a Salt event acknowledging that it was shut down, and we can watch the capacity drain out of the system. Works great. And the whole time Monit is letting us know, okay, for this service, I've got 10 servers right now. Each of them are now handling, say, 5 or 6 jobs. And we can say, well, that's well within norms. We worry once we get to, say, 20 jobs. And we can watch it fluctuate as that goes on. Some of the stuff that has gotten us in the past as far as scalability goes, message TTLs are really finicky. So you've got a job that's going to take an hour, and we want it to get serviced within like a minute from a user's perspective. Figuring out the right TTL there is pretty important because you don't want to have a TTL that's close to an hour. Otherwise, if you time out your job and you put it back on, you've now doubled the processing time, and that's no good. But if you're timing out too quickly, you're going to ramp up scalability before it will even really help you. So if you're responding within 2 minutes going, I need a whole bunch more capacity, but each job takes several hours, you really have no sense of what your overlap is on your jobs over the past hour that are currently affecting your server. So we've had to do a lot of experiments there where we try different TTLs to kind of see how the responsiveness of the system pans out versus the throughput of the system as a whole. In our situation, the queue or the job broker is really critical, and understanding how partitions work is really important. So we can run RabbitMQ in a 3 cluster scenario, but we need to know really, really well what happens when one node drops out of that cluster. Do messages stay with that node? Do they get moved over automatically? And what do we need to do to respond? Those sort of partitions don't happen very often, but when they do, you need to be really sure that you don't lose any data. And so it's well worth investing several days' work of engineering effort just to say, let's simulate one of these and see what happens. You want to deal in average loads, not point thresholds. I kind of mentioned this before in the sense that your sort of burstiness of your traffic is going to have certain characteristics, and you don't want to be responding to just the bursts. You want to be responding to the averages because your infrastructure is going to bounce at a certain latency, right? So if your signal is really rapid, but you can only change your servers so fast, you need to average out to approximately how fast your servers can respond. And finally, I already mentioned that stepping back the resources is really key, especially as you're figuring out kind of the interplay between the speed at which you respond and how you deal with the averages versus the spikiness. Stepping back resources is a great way of getting a feel for that without committing. In fact, for the first little while, it was really helpful for us. Instead of saying, all right, we're going to commit shut down servers, we would just say, shut down processes, and let's just wait and see what happens, and then bring it back up. And it's a good way for us to experiment with different thresholds and different averaging techniques to get a sense of things. Rolling deployments. So once we had built all of that, getting actual rolling deployments was surprisingly easy. We just think of rolling deployments essentially as we're going to scale up, but only with the new code. We're still going to monitor and make sure that we're handling the same throughput we had before, and then we scale down any of the older servers. That's it. I mean, if you've got the scaling up and the scaling down, all you need is the coordination of which server is old and which server is new, and you can handle rolling deployments. And again, like I mentioned, we get signals. We use Salt Cloud in order to bring infrastructure up and down. And we get signals via Salt Cloud when a new node comes up, when it goes down, when it enters some of these, not like system level states, but more like hardware level states. And that makes it easy for us to have a trigger that is essentially stateless. So Salt doesn't need to say, I'm going to do a rolling deploy. I'm currently on server X. Instead, it just says, OK, I'm going to eliminate whatever the oldest server is. I don't care which one it is, one of them. And then it just forgets. A couple minutes later, our provider comes back and goes, OK, I just terminated server X. And Salt goes, OK, thanks. I don't know why I care, but thanks. It doesn't need to keep a consistent view of, I'm doing these rolling deploys. Instead, it's just saying, I know how to respond to each of these events by itself. I have too much capacity, drop the oldest one. I just got a new server, high state it, add it to the pool, make it work, that sort of thing. Of course, the timing and metrics are really, really service specific. So we found that all of the key metrics about when something is up and when it's working is very different between our different services. We have to have a really deep, in-depth understanding of how they work. Working from the standpoint of like, we'll just consider if a server has been up for 15 minutes that it's good and we'll leave it alone, bad way to go. All right, so our final architecture is Salt the Burninator in the middle. It interacts with each of these different components. So it's talking to AWS EC2, it's getting responses back, it's reacting to those. It's talking to Sentry, getting information back from Sentry so that we can do things like, okay, I just shipped this new code, it ran all the unit tests, but it turns out that we didn't update a configuration file. And Salt can very quickly see, all of the servers on version 3 are spouting errors as quickly as they possibly can. And all the servers on version 2 are OK. I think we're not going to run 3 anymore. And that works really great at the application level. At the monit level, we tend to hit a lot more of this node lost network connectivity or something like that. Or it's out of file handles. That happens sometimes too. But that's often more of an application layer concern. But anyways, that's the sort of thing monit will catch. And again, talking to Salt, Salt can tell monit, OK, you don't need to freak out quite so much. You're in the middle of deploying stuff. And Monit can say, I'm freaking out because I was unable to recover automatically the way I've been taught. But putting salt in the middle makes everything easier because it's, for us, the right place. And it's a place where we can have reactions and responses, a place that already knows a bunch of state about the infrastructure, and a place where we have all of the tooling appropriate to debug what's going on, to fix things that are going on. And so essentially pushing Jenkins out to the side has worked really well for us. What would I like to see in the future? Kind of like everybody, I think containers looks interesting. I'm hesitant. I haven't really figured out how Salt fits with containers. I'm glad there's some sessions here at this conference that talks about this a little bit. Mostly, I would like to see higher utilization of the resources that I pay for, CPU, memory, that sort of thing. With as many tiny services as I have, it's kind of annoying the fact that I'm essentially deploying one service to one server and I'm not always utilizing it. I would prefer to have like a vanilla server and then some sort of container management that moves it around. That'd be really neat. But I haven't really figured out how that's going to work with Salt, and that's something we're kind of working on. Hybrid cloud environments, yay, buzzword bingo. Hopefully somebody just won. That's more about local installs. We have customers that like our product, but they don't like the fact that it runs in our cloud. They want to run it in their data center. And so we're working on figuring out how do we make Salt work in a reasonable way, especially in scenarios where we're air-gapped so we can't get communication with their deployment. Salt helps us get all that stuff spun up, but we're trying to figure out how do we balance developing Salt states for our cloud stuff and then porting them over so that we do this one-time install with occasional service reps going out and helping people. Automated load testing is important to us. We do a little bit of load testing, but really not enough. It would be really cool if we could have Salt spin up a whole bunch of, a new server and then a whole bunch of things to basically bombard it and make sure that it's working right. That'd be neat. And finally, Travis. Jenkins is fine. It's a very reliable tool, but the thing that drives me crazy about Jenkins is it's very difficult to do configuration management for Jenkins itself. It's not like I can just write a YAML file and it will populate all of my jobs and their histories and their interdependencies and all that stuff. Travis is much better at that sort of thing. And so we're tending to look favorably at Travis as a replacement for Jenkins because it just fits a little nicer in the everything is managed by stuff that gets checked in. And I'm pretty sure Jenkins can do that. It's just not easy and it's not great. But these are kind of the directions we're going in. I feel like a lot of people are going there with us. And that's the end. Congratulations, you survived. As a reminder, since the organizers have asked me to do this, please rate my talk on the app. Be blunt. I have a thick skin. I don't know any of you. You're not going to hurt my feelings. And email and Twitter and all of that stuff. Questions? Over here first.
When you have to get stuff back from Salt into Jenkins, for example, let's say unit tests or some kind of integration test like an end unit or a unit file, how do you manage that if Jenkins is just kind of an asynchronous, send it and forget it?
So the question was essentially, how do we get data back from Salt into Jenkins, particularly related to integration tests and load tests and stuff? The answer is we don't. I don't know anybody who does. You probably could. It's pretty flexible. But for the most part, we like Jenkins being really, really dumb in the process and being unidirectional. Most of everything else talks to each other. Jenkins is one of the few components that doesn't. It just does its job and emits events. That might be disappointing, but that's where we're at. Sorry, over here first.
Sure. You don't like using the Salt API with Jenkins. You were using the Jenkins plugin, the one that was built. Were you previously, before you moved on to using events?
OK, so the question was, we didn't like using Jenkins with the Salt API. Were we using the Salt API plugin with Jenkins? Yes, we were. It was, we basically were like, Jenkins, Salt, Google. Oh, look, there's a plugin. Install. That's about as much thought as we gave it. And it worked fine for what it was meant for. It's a fine plugin. I just think philosophically it was not a good way for us to go, for Jenkins to need to understand. And honestly, we could have ended up with all of those projects using the Salt API plugin to emit events, and that would have been perfectly acceptable. It's not how we did it, but I don't see any reason why not. But the fundamental philosophy we were trying to avoid was we don't want Jenkins to know anything about Salt except enough to say, I built this. Did that answer your question?
Yes, and then I was going to do a follow-up question. Was it only the lack of color in the output that caused you to move away
That was a factor, but not the only one. Tying up a worker cost us a lot, mostly because we don't have a big enough team that we need like scores of workers. We keep like 2 or 3 around, so tying one up for 5 minutes was bad for us. Not knowing the status was bad, not having the colors was bad, but really the bad thing was the architecture of Jenkins knows about too much. Is there another question over here?
So mostly you're using Jenkins as a scheduler then? I guess, primary.
So the question is Jenkins mostly used as a scheduler?
Yeah, or if you're doing something else that could be done by some other.
Yeah, so we use it. We do builds on a couple of different operating systems, Windows, some ARM systems, some Linux systems. And so it mostly schedules the work of performing those builds across those different services. That's pretty much it. So it's really good at that. As far as I understand, that's the basic use case for Jenkins.
And reporting.
Yeah, and we do use the reports a lot too. It's really great for Jenkins to be like, this job failed. Here is your tests that failed. Here's the stack traces. Here's your coverage report. Blah, blah. Great for all of that.
But you're not using that.
Oh, we are using that piece. It just wasn't really pertinent to this talk, so I didn't really bring it up. So that's before we ever get to deployment. That's kind of a developers develop something and their test shows that they didn't develop it right. So it kind of stops before it gets to any of the infrastructure.
Okay, so for unit testing.
Yeah, we use Jenkins for unit tests. Yeah.
So why did you choose not to use a CD tool like TeamCity or Bamboo or GoCD to manage your deployments, which also include further testing and rollbacks?
So the question was, why didn't we use a commercial product like TeamCity or Bamboo to actually do continuous delivery like a proper shop? The answer is probably twofold. One, nobody thought about it and suggested it. And two, if it cost money, I might have said, this costs money. That's not a great reason because we're not averse to spending money to save a whole bunch of effort. But this ended up being very incremental. I mean, it was essentially like scratching an itch at each step rather than sitting down and being like, we're going to do continuous delivery. I mean, we did sit down at the beginning and go, we want to do testing and we want to do continuous integration. But it was less intentional than let's put a bunch of vendors on a board and pick one, and more like, these are principles we believe in, and we'll find tools that'll do it, and we'll just kind of churn forward. It's not a great answer, but it's very startup-y.
GoCD is open source and free.
Awesome.
And I've got another question.
Sure. I haven't seen any other hands. Go ahead.
As far as system configuration, if you're using Jenkins better to roll out code, but how are you managing any system changes? So adding users, what if you need to push out a new SSL cert? It's not actually part of code deployment, it's part of more system configuration. How would you go about managing those changes?
Okay, I'm going to see if I can encapsulate that question. So the question is, how are we managing sort of system level configuration changes such as swapping out an SSL cert or adding a new user or taking a user away from the system? Did I get that? Okay. We actually do it all with Salt. So we have one state in Salt with a bunch of pillar data, and it is the list of users that should be installed on the system with their preferences and their SSH keys and all of that stuff. And every time we high state, we run through all of them and we fix it. It makes our high states a little bit slow, but it was really easy to get started. And SSL certs are kind of similar. Previously, we had a manual process where I'd go with a credit card and I'd get a new wildcard cert. I'd check that into a pillar, basically, and then we mapped, okay, these web servers have access to this pillar. They're going to deploy this key. We're now moving towards Let's Encrypt, which basically means we don't have to do any of that. We just have a pillar that says, here's my DNS entry, renew it every 3 months, and that's working well for us. But yeah, it basically all boils down to we pretty much use Salt for everything, put it all into pillars and states. Yeah?
So it was a new version and it doesn't work. What's going on?
It kind of depends on how it doesn't work, but in general, what happens is Salt says the server is up. That implies that Monit and Sentry are in place in some capacity. If they aren't, we're not very good at detecting that. Like say the service has provisioned the resources, but Salt has failed to fully high state the first time. Doesn't happen very often anymore, but back when it did, like it was hard to catch. But assuming that we got that high stated, Monit would come in and either say, one, the application process is not running, it's not running, it's not running, and Salt would go, okay, abort. And it would spin the server down and it would tell a developer. Because in that case, it could be that we have a provider outage, like Amazon has some sort of network failure or it's giving us bad nodes or something, and we may need to get a human being involved. Sometimes that won't work. We'll bring up another server, go through the whole thing again, and that will be fine, like in the case where we get a single bad node, and that's okay. A developer's usually been alerted, but it's infrequent enough it's not an inconvenience. But it basically boils down to, we have the expectation, so Salt has been given an alert, I have a new node, it has the expectation that the monitoring system is going to start feeding it data saying, this is up. And if it's not, we got to do stuff about it, which is usually shut it down. If it's an application level problem, the same applies, because Salt basically has one big club, which is beat the server to death because it's naughty. And so it's really a question of, how do we tell the developers that something is wrong? Is their code wrong? Is the infrastructure wrong? Either way, Salt's going to shut it back down. But we just need to tell the developers, okay, you either need to check in new and better code, or you need to get on the phone with Amazon to figure out what's going on. And those are basically our two failure modes. Yeah?
How do you know to go back? Like, so you said you have a certain version of code that's not doing well, and you want to roll back to version 2. How do you know which version is what?
So all of our services follow the exact same model of deployment, which is our master branch is where we're doing development. Whenever we do a release, we're going to tag a particular commit on that master branch. And Jenkins, when it runs the tests and it packages up this code saying this code's ready to go, it's going to use that version and that SHA. And so those all kind of go along with whatever is deployed. Any alerts that go to Sentry about stuff going wrong includes that version information. And so in Sentry, we can go in, and Sentry will be going bananas, going, there's all kinds of problems. And we can look at the problems, and it will say 100% of these errors are from version 3.47, which is Git SHA this. 0% of these errors are from everything else. And then we can go, well, somebody did something bad. Again, Salt is shutting down the servers that are bad because we bring them up, and so we're not basically polluting our pool with these bad servers. But when that happens, and it's relatively infrequent because of our testing, a developer has to get involved. And they have to start figuring out, okay, Salt can say, these servers are down. They had this version number. A developer then has to use their brain and go, oh, oops, I forgot a semicolon, crap. We don't usually roll back. We tend to roll forward. So if there's a problem, unless it's a problem that only hits production and not dev, which is thankfully fairly rare, we tend to go, okay, this failed in dev. Let's fix our code and keep going, rather than going, check out whatever it was last week that was working. We hit that infrequently.
You shut down what you shut down the new code you deployed.
Yeah.
Shut that down so it's no longer in, so then figure out what's wrong.
Yep, exactly. And since Sentry captures all the stack traces and everything, it makes it fairly easy most of the time. We don't usually have to log into servers to look at what's going on. Anybody else? All right, well, I'm over time. Thanks, everybody.